All right, folks. So today we are going to talk about circles. Okay. So circles, what are they really? Like most middle school and high school students don't even know like the actual textbook definition of a circle. Okay. So a circle is essentially defined by the points that are equidistant to a center and form a shape with no vertices. Okay. So this is a kind of shape that has a very, very specific ratio between its perimeter essentially and the diameter, okay? That's pi, okay? And a circle is essentially just a bunch of points which are equidistant from a center, and a center could be any random point on the coordinate plane. Okay, so let's go over some basic stuff. Okay, so let's look at the perimeter. The perimeter of a circle is given by 2 pi radius, or 2 times pi radius. Or, as you could say, just pi times the diameter. And the area of a circle, on the other hand, is given by pi times radius squared, okay? So first you need to square the radius, then multiply by pi. Pi is a very, very interesting mathematical concept. You get to see pi in many different areas. You could even look at pi in some of the data we have collected from the Chandra Observatory in NASA, and how that kind of looks at the effects of general relativity. And you could see that pi is encoded into the data, okay? So pi is a really, really good mathematical concept, and I would recommend that all of you know at least 5 decimal digits of pi, if not more than that, okay? All right, so pi is essentially equal to 3.14159. Okay, remember that. That's really important. I mean, in most mathematical calculations, you would just use 3.14 or 3.141, but just for the sake of just knowing stuff, it's really good. And just to give you a bit of insight, NASA uses pi to calculate the trajectories of various satellites and orbiters it sends around different planets, and you will really use pi in physics a lot, especially orbital mechanics and just general Newtonian mechanics. And they essentially use pi to the 12th decimal place, and after that, it just gets super irrelevant, okay? But for some reason, supercomputers around the world are still calculating the digits of pi. We are up to about 2.1 trillion digits of pi, okay? But it's a really waste of time because even NASA doesn't use more than like 12 digits of pi, okay? So I guess you guys would be fine with just 2 to 3 digits of pi, okay? So now let's get into a really, really interesting topic, okay? It's called radians. So radians essentially is a different way to measure angles in terms of pi, okay? This is really important to understand. There is a certain relationship between pi and degrees, and that is that pi radians is equal to 180 degrees. So essentially, 360 degrees is equal to 2 pi radians, okay? Radians is often written as RADS, rads. Just my handwriting is somewhat bad. And 1 radian, okay? 1 radian, not pi radian. 1 radian is defined by 180 over pi. All right? This is really important because these are concepts that you would see in essentially math 3, pre-calculus, and some part of calculus, okay? So it's really important to understand this area, okay? This is the part. Radians is equal to pi over 180 times degrees. And degrees is equal to 180 over pi times radians, okay? I want you guys to take notes and really understand this concept, okay? This is a very major part of Math 3, okay? Let's move on. So essentially, let's do some problems. It is the best way to learn something, okay? Is to do problems. All right, so let's look at the first one. It says convert 23 pi over 20 radians to degrees. All right, we know that 2 pi is equal to 360 degrees, right? Okay, we know that. So what we do, we say that there are x degrees. We do 23 pi over 20 all over 2 pi is equal to 360 over x, right? Now you simplify this, okay? So essentially you simplify it down to 23 pi over 20 times 1 over 2 pi is equal to 360 over x. Okay, so you could cancel out pi and pi, and that gives you 23 over 40 is equal to x over 360, right? From here, it gets really simple, okay? So it's essentially 40 times, sorry, my bad. So it's 23 times 360 over 40 is equal to x. You cancel out zeros, you cancel out 4, 9. 23 times 9 is equal to x. Now in order to do that, 23 times 9, that's fairly simple calculation. That would account to 207 degrees is equal to x. Right there. It's that simple, okay? Let's take a look at this problem. Convert 100 degrees to radians. Now that's really simple because we know that you just set up a proportion, right? Is equal to x radians over 2 pi, right? That's fairly simple. You know how to do that. That equals to 100 times 2 pi over 360 is equal to x. You cancel that. You cancel that. That's 18. Now you cancel that. That's 5. So x is equal to, I should say x radians is equal to 5 over 9 pi. It is that simple, okay, people? It's really simple to convert from these kinds of things, okay? I hope you're taking notes, and if you have any questions at any point of time, you could just simply unmute yourself and ask right there, because I want to make sure that all of you have a really solid background knowledge of circles. And when you enter high school math, you should be really confident with these concepts and really be at the top of your class because you put in the extra time to study math over the summer, okay? Study advanced math over the summer. Okay, so let's look at this really great concept called arc measures. So arc measures are in degrees, and to find them, you need to know things like vertical angles and that a line forms 180 degrees. Now that is fairly simple. Most people in middle school know that vertical angles are equal and that a line forms 180 degrees. Now, It says in the figure below, line BD and EC are the diameter of circle P. What is the arc length? What is the arc length of the minor arc AE in degrees? So essentially talking about this little angle. We know that the total measure is 180. Is 180, which is equal to, we know that this small AB, this small part, is a 90 degree, plus it gives us 63. And let's call the other angle X. So 180 is equal to 153 plus X. So X is equal to 27 degrees. That is simple. Okay, that was just an introductory problem. Now, let's move on to something more difficult. So once you know the degree measure of one arc and the circumference of the circle, you'll be able to find the arc length. Okay? So in these kind of problems, they would essentially give you a angle where you need to find the angle, and they would give you the radius or the diameter, and then you need to find the circumference, and then you need to set up a proportion, okay, essentially. So let's look at problem 1. It says, what is the length of arc DC? That's this bigger arc, okay? Remember how I talked about vertical angles? As you can see, angle DPA and angle CPB are vertical angles, right? So this is also equal to 60 degrees. And we know that a line is equal to 180 degrees. So we could say that DC is equal to 120 degrees, right? Okay, and now they give us the radius. So we find the circumference. Circumference is 2 pi r, which is equal to 16 pi. Now we set up a proportion. So 120 over 360 is equal to, remember the circumference was 16 pi, and let's call the length of DC, sorry, my bad, 16 pi, and let's call the length of DC. Now, to calculate X, it's fairly simple. Just need to do this over 360. Cancel out the zeros, cancel that out. That's 1, that's 3. So X is equal to 16 over 3 pi. That is easy, right? That is really easy. No? I wish I had someone to teach me. All right, so let's look at this problem. It says, what is the length of arc ABC? Essentially, this entire bad boy. Okay. Know that the total angle is equal to 111 plus 129. That is equal to 240 degrees. Now we set up a proportion. And wait, it gives us the radius. So we find the circumference. That is 12 pi. Okay. Now we set up a proportion. So 200, oh God, okay. 240 over 360 is equal to 12 pi over x. Now we could just essentially solve. That's equal to 3, that's equal to 2. Now we cross multiply all of this to 2 over 3 times times 12 pi is equal to x. That cancels out. So x is equal to 8 pi. All right? That's fairly simple.
Mm.
All right, so let's look at some, all right, arc length. As I talked about, arc length over circumference is equal to arc measure over the radians in a circle. Okay, basically, that's fairly simple, right? And to remember, in order to solve these kind of problems, you need to remember this. Okay, arc length over the circumference. Sorry. Oop. And let's go back. Yep.
Mm.
Okay, so you need to remember arc length or circumference is equal to arc measure over the radians in a circle. All right. All right. Let's move forward. So essentially, ooh, did I miss a? All right. So I want to go over this concept first. All right. So someone's asking me in the chat, is it an arc? Yes. I'm talking about arc, like in this kind of thing where it says AB, or it says this like dome kind of thing. That's arc. Okay, that's this area, this bad boy. Okay. All right. So let's look at inscribed angles. It's a really simple concept that I want you guys to know before entering high school. Essentially, so in this scenario, this is a circle and O is the center of a circle, okay? So the angle formed by the central angle is angle BOA is called the central angle, is equal to, let's say, hypothetically, it's equal to us, is equal to, I don't know, 36 degrees. Okay, that's called the central angle. Let's look at this angle at P, okay? BPA. This is a really important concept. BPA and BOA essentially encompass the same arc, AB. Okay, the arc they have is AB, right? Actually, this arc. Okay, so if they have like these two sides of an angle, so the arc between them is the same, right? So essentially, the concept is that the angle at the center would be twice in measure, in degrees measure, okay, than the angle which has a point on the circle. So BPA would be 18 degrees, okay? This is a really, really good concept to know. And when I took the AMC last year, I guess it was like problem 6 or problem 7 AMC 10. I'm talking about AMC 10. I guess it was problem 6 that they asked, like, draw a circle, and then you have like this angle in the middle, and then you have this like angle which has a point on the circumference of the circle. And I drew all that, and it simply came down to knowing this concept. And I did know it because I went through a lot of AOPS books. So that was a easy 6 points on the AMC. Okay, that was really easy 6 points. I know a lot of people would have been like, what? Do I need to prove something? But these are really, really, really simple math concepts that we could build on. And I would recommend that you guys definitely try out some competition math, okay? At the end of this, I would try to kind of get you guys acquainted with competition math. Okay. So now let's look at this problem right over here. It's a bad boy problem. Okay. This is a complex problem. So first of all, I want you guys to try out on your own. Okay. I would give you 2 minutes. Okay. I will give you 3 minutes to solve this problem. Essentially, you need to find the measure of arc length BCA. Sorry about that. You need to find the measure of arc length BCA. BCA. Okay, you need to find out BCA. You have 3 minutes and then we'll go over it. Okay, go. Essentially, this problem is talking about finding the arc length of BCA. They give us an angle BPA in terms of radians. Okay, what do we know about radians? That 360 degrees is equal to 2 pi radians, right? And we see that BCA is the rest of the angle. So essentially, the measure of BCA in degrees is 2 pi minus 3 over 10 pi. Now to solve this, we get it on the same base. 20 minus 3 pi is equal to 17 over 10 pi. That is the angle measure of this black part. Okay, this angle measure. Now that we know that, let's move on. They give us the radius. Okay, what could you do with the radius? You could essentially find out the circumference of the circle. Okay, so the circumference is 2 pi r, which is equal to 50 pi, right? All right, now we could set up a proportion. Let's set up a proportion, right? It would be really easy to set up a proportion. We know that, let's call BCA x. So x over the circumference was 50 pi is equal to 2 pi, because radians, right? 2 pi over 17 pi over 10. I should have written that better. I'm sorry. My bad. 17 pi over 10. Whoop. Now, as we have seen in the previous slide, that arc length over circumference, so arc length x over circumference 50 pi is equal to arc measure 17 over 10 pi divided by radians in a circle. Radians in a circle is 2 pi. Okay, now we solve this problem. How do we solve it? Let's see. Okay, first of all, what we need to do is essentially say that x over 50 pi is equal to 17 pi over 10 times 1 over 2 pi. Pi cancel out.
Can you write that part down? I can't see anything.
This.
Huh? Oh, sorry, my bad. Could you see it now? Hey.
Yeah.
Yeah. That was my bad. Do you guys want me to start over? I'm good with starting over.
I think it's fine. I don't know.
Hold on.
Okay. As you can see, like you need to find the angle measure. That would be 2 pi minus 3 over 10 pi. Okay, that equal to 17 pi over 10. And we have the radius, so we can find the circumference. Okay, and now we're just solving. We set up a proportion, and now we're just solving. Okay. Okay. So essentially, I would write that again. X over 50 pi. 50 pi is equal to 17 over 20, as I remember. Now, what we could do is essentially x is equal to 17 times 50 pi over 20. That cancels out. 17 times 5 is equal to 85. So this is equal to 85 over 2 pi. Okay? That is essentially what this problem's about. Now, let's look over a very, very, very interesting concept and one of my favorite concepts in the mathematics of circle is the equation of a circle, right? So the equations of a circle tells us the relationship between the center of a circle and the radius of a circle. Essentially, this is a way to describe a circle in a coordinate system, like we could describe a straight line in a coordinate system, or we could describe some other figures in a coordinate system, like a square using 4 different lines that are perpendicular to each other, right? This is a way for us to describe this is essentially a way to describe the relationship in that, right? Okay, so it says this is the standard form of the equation of a circle, and it is centered at A. Remember, the center is h comma k. So h is equal to your x value, and k is equal to your y value with the radius r. Now, where this gets tricky for a lot of people is that they forget that it's r squared. So if you encounter an example where it's given equal to 25, people might simply think, oh, the radius is equal to 25. No, the radius is equal to the square root of 25. That is equal to 5, right? And some people might forget that both of these are negative, right over here, negative h, negative k. Right? So if you're given x plus k in some example, the center is, or the x value is actually negative k, because this is essentially equal to negative h, right? Now let's look at some things using the equation of a circle. So in some problems, in like a lot of standardized testing, they do this. They might give us the expanded form of a equation of a circle, right? And they would ask what is the radius or what is the center? So essentially, we need to convert it from this expanded form to the standard form that we know. How would you do that? Well, you need to understand a technique called completing the square, okay? If you have x squared minus 2x, let's say, hypothetically, is equal to 0. Okay, that sounds okay. All right, so I'm sorry, let me change this. X squared minus 4x is equal to 0, okay? What you could do in order to find out, this is called completing the square, right? You could add a third term, so c is equal to 1/2 b squared. So essentially b over 2 squared in completing the square, right? So in this particular example, c would equal to b over 2. So b is -4 over 2 is -2 squared, which is equal to 4. So you could add 4 to this side, but you need to remember that in math, we add, subtract, divide, whatever on both sides of the equation. So you add 4 here. So that would be x squared minus 4x plus 4 is equal to 0. Nope, I made that mistake once again. Is equal to 4. Now, you could do is, you could take that, now you could put this into a square form. Right, do you guys agree? That x squared minus 4x plus 4 is equal to x minus 2 squared, which is equal to 4. Now we can subtract 4 from both sides to get is equal to 0. Now, look at that. That could essentially tell us the circle equation of a circle. Now, we just need to put it in 2 different forms, okay? You essentially just need to put it in 2 different forms. So if you have this says x squared minus 2x, and the other part says y squared minus 4y. And I would recommend moving this -4 over, which is all equal to 4, okay? Let's convert these to their desirable forms. So x squared minus 2x plus 1, because -2 divided by 2 is -1, and then square it is 1. And this would be y squared minus 4y plus 4, because -4 divided by 2 is -2, -2 squared is 4, right? Now, we could take these into this form as I talk. Now, we could take this part over here and go to x minus 1 squared. This would be y minus 2 squared. And remember, we added 1 and 4. So we added total of 5 on this side. We need to add 5 on this side. So the grand total is 4 plus 5 is equal to 9. So as you can see, this is now equal to this original equation we started with, x minus 1 squared plus y minus 2 squared is equal to 9. And the radius is 3. And the center is 1, 2, like this here. Okay, this was a fairly simple concept. And this is often tested on standardized testing like SAT, ACT, and as an experienced SAT person who has scored scored in the 99th percentile, I am telling you, just knowing the equation of a circle and what it means will get you free 50 points on the SAT math section. Okay, just 3 points essentially. All right, so let's take a look at these problems. As we see, we have this big old equation, and what is the center, and then what is the radius. This is fairly simple. Let's look at the center. We know that this x plus 4 is basically x minus -4, right? Ooh, I can do that better. So x minus -4. So center x value is 4 and y value is 6. So -4 comma 6 is the center of a circle, and I write 6 because y minus 6 that doesn't have any changes done to itself. Okay, and so this is -4 comma 6. And what is the radius? Radius is essentially the square root of 48. The square root of 48, now that is equal to 16 times 3 is equal to 4 square root 3, right? That is the radius of the circle. Now let's look at problem 2.1. The circle has a radius square root of 13 units and is centered at -9.3, comma 4.1. Write the equation of a circle. Let's do this. Essentially, it's talking about, we see that there's a -9.3, so x would turn positive 9.3 squared plus y minus 4.1 is equal to, now we take the square of that. The square root of 13 squared is essentially just 13. So that's equal to 13, right? That's very easy. Okay, so let's move on. As you can see, this is how you would solve an expanded form of a circle into getting the desired form using the process so-called completing the square that I just talked about. So this is an example problem. As you can see, you are given x squared plus y squared plus 18x plus 14y plus 105 is equal to 0. Now they tell you that's the equation of a circle. You may say, that doesn't really look like an equation of a circle, okay? But you need to use your big brain, okay? Use your big brain to turn this into your desired form. Turn this bad boy into this, right? Into this. How would you do it? Well, all the steps are right here. All the steps are right here. Okay, as you can see, you would take 105 and put it on the other side, -105. You would do completing the square, x squared plus 18x. 18 divided by 2 is 9. 9 squared is 81, right here. And then y squared plus 14y. 14 divided by 2 is 7. 7 squared is 49. You would add these two over here, getting this. X plus 9 squared plus y plus 7 squared is equal to 25. So the center is -9 comma -7, and radius is 5 because square root of 25, right? This is fairly simple. Okay, So do you guys have any questions, comment, or concern? How are you guys doing? You could unmute yourself and talk to me. And